Okay, so here we have another free fall problem example, but in this case we have an object that's being launched upwards. So it's going to go up and come back down. So it says an arrow is fired vertically upward into the air with a speed of 100 meters per second, and there's three parts to the question. How long does it take to reach its peak? How high does it go? And how long is it in the air in total? Okay, so when we're working on a problem like this, once the arrow leaves the bow, we know that it's in free fall. We know that any object in free fall is going to have an acceleration of negative 9.8 meters per second squared. We know the initial velocity of this arrow is 100 meters per second, and that's positive because it's moving upwards when it's launched. And if it's asking about how long does it take to reach its peak, it's critical for us to understand that when an object reaches its peak, its velocity is zero. So at the very top, the end of that motion, think of the end of the motion from firing up until the peak being the end, the velocity is going to be 0 meters per second at that point. And we want to know how much time does it take to reach its peak. So if we think about our kinematics equations, the equation that we're going to use here is VF equals VO plus AT. But we're solving this for t. So in order to get t by itself, we're going to subtract VO from both sides, and then get VF minus VO equals AT. And we can divide both sides by the acceleration in order to get t by itself. All right, so now we're all set. T equals VF minus VO over A. So we'll plug in our numbers. VF is 0. VO is 100 meters per second. And the acceleration is negative 9.8 meters per second squared. All right, so we have negative 100 divided by negative 9.8. So 100 divided by 9.8. And I get about 10.2 seconds. And this comes out positive because we have a negative number over another negative number. So 10.2 seconds to reach its peak. Next question is, how high does it go? Well, how high, if we think about that, it's asking about how many meters, how far does it go? So we're going to use our delta y equation here. So delta x or delta y equals VOT plus 1/2 AT squared. And in this case, we know VO is 100, and the time is 10.2 seconds. And then we have plus 1/2 times negative 9.8 times 10.2 seconds squared. So we need to be pretty careful here. I'm actually going to do this in 2 steps. So 100 times 10.2 is 1020. That's this part. Plus, and then I'm going to do the second part. 1/2 negative 9.8 times 10.2 squared. Gives me negative 509.8. So if I put those two together, 1020 plus negative 509.8, one second there, 1020, 509.8. I get 510.2 meters. Which is pretty high, but again, we launched this thing at 100 meters per second, so it was moving pretty fast. Okay, and then the last question, how long is it in the air in total? Well, if an object is launched vertically, goes up in the air, comes back down, if it's coming back to the same height again, we know that it takes the same amount of time to reach its peak as the amount of time that it takes to come back down again. So if we look at the answer we got for A, we know that it's just going to be double that amount of time. Time up equals time down to equal heights. So the total time equals 10.2 seconds times 2, which is 20.4 seconds. And there we go.